Hey, everybody. Today we are going to be taking a look at the last topic for this chapter. We're going to look at how we can use areas to determine probabilities for things like throwing darts at a dartboard. But we'll get to that a little bit later. First, if you haven't thought about probability in a while, I'll just remind you normally, when we think about probability, we think about it in situations like we're flipping a coin. The probability of having a result of tails when I flip a coin is 1 out of 2 because there's one outcome that is tails out of the two outcomes that are possible, heads and tails. So since one of the outcomes is what we're looking for out of two possible outcomes, 1 out of 2 or 1/2, 50-50 chance. If we roll dice, if I've got two dice, two six-sided dice, there are 36 possible outcomes. The blue die over here on the left side could be the numbers 1 through 6. The green die could be also the numbers 1 through 6. So there's 6 possibilities for the blue, 6 possibilities for the green, 36 total possibilities. Of those possibilities, if I want to know what's the probability of rolling a sum of 5, well, if I roll the dice, well, it didn't happen this time, but one way we could get 5 would be if I rolled a 2 and a 3. But that's not the only way. We could also have a 3 and a 2, a 1 and a 4, or a 4 and a 1. And because there are 4 different ways that we could roll a sum of 5, our probability is 4 out of the total of 36. If we play Powerball, the probability of winning a Powerball jackpot is, well, very, very, very small. It's not very likely because there's millions and millions of possible outcomes, and only one of those outcomes is the one that matches your numbers. And so in this case, we've got 1 divided by 292,201,338, and that's a very, very, very small number. Even though there's two outcomes, you win or you lose, there are millions of possibilities, and so our probability is, well, the probability is the number of successes. There's only one divided by the total number of possibilities. Basically, probability is this formula, the only formula that we really need for probability. The probability of something happening, whether it's flipping coins or buying Powerball tickets, there's the number of successful outcomes divided by the total number of outcomes. Now, in terms of area, what we're going to be doing, the probability of an event happening is the area of a successful region. Instead of flipping coins and rolling dice, we'll take a look at the size of a region compared with the total area of all of the possibilities. And so these areas, this is what we've been talking about, what we've been studying in this chapter. Um, Area of success divided by that total formula. In a case like this, it's a nice simple case. This is kind of like flipping a coin. I've got two possible outcomes. You can imagine this like it's a carpet, and you're going to drop a ball somewhere around this carpet. And so maybe the ball lands over on this side, or maybe the ball lands over on this side. And so you've got one outcome that's landing on the white part, one outcome that's landing on the blue part. They're both the same size, so it's a 50-50 chance of it landing on the white part or on the blue part. If I've got more regions, each one of these regions is the same size. And so since I've got 4 equally sized regions, the probability of it landing on the white part is 1 out of 4 possibilities. Probability of landing on the purple part is 1 out of 4 possibilities, but the probability of landing on the blue part is 2 out of 4 possibilities. So 2 out of 4 reduces to 1/2, 50-50 chance of it landing somewhere on the blue part. And then if I get just a little bit more complicated, take that white region and cut it in half. Now, even though I've got 5 different regions, they're not all the same size. So we might even have to think about it by breaking these all up into regions that are the same size, so then we can count. With 8 regions, I've got 1 out of 8 that is yellow. I've got 1 out of 8 that is white. So the probability of yellow is the same as the probability of white, and that is 1 out of 8. Here I've got 2 out of 8, so the probability of the purple is 1 out of 4. 2 out of 8 reduces to 1 out of 4. And then the blue, I've got 4/8. 4 of those 8 regions are blue, and so 4/8 reduces to 1/2. All of these fractions better add up to 1. An eighth plus an eighth plus a half plus a fourth should add up to 1 because that's the total um, amount of possibilities there are. Now, for the problems that we're going to be using, it's going to be more about the formulas that we've been learning in this chapter. So maybe instead of just all these evenly sized regions, maybe I give you a carpet that looks like this. I've got this big, beautiful white carpet. I've got one rectangular region that's green. I've got another one that's pink and another one that's yellow over here. And I might ask, what's the probability if I just throw a ball up in the air and it lands somewhere on this carpet? What's the probability that it lands in the green or the pink or the yellow region? And so thinking back to this, the area of a successful region, if I say, what's the probability that it lands on the green? The area of this successful region, well, it's just a rectangle. 80 times 30 is that area divided by the area of the total. The total carpet here is 360 feet by 150 feet. That's quite a big carpet. It's actually more like a football field. But that's how we're going to figure out the probability. The probability of green, 30 times 80, that's the probability of just the green region, divided by 150 times 360, that's the area of everything all put together. And when I plug that into my calculator, I get 0.04444444. I'll round that to 4.44%. And I can do the same thing for the pink region. The area of the pink region is 60 times 100. But the area of the total is still the same, 150 times 360. Pink region must be a little bit bigger because I get about 11.11% probability that it lands there. And then the yellow region's a lot smaller, but it's the same process. Probability of yellow is the area of the yellow, 10 by 20, divided by the area of the entire thing. When I plugged that into my calculator, I got 0.0037. So I rounded that to 0.37%. And then finally, if I want to take a look at the area of the white region, this fits into the category of the irregular figures that we talked about yesterday and a little bit before break, where the area of the white part would be the total area and then take away each of those colored areas, leaving us with just the part that's white. I'm not going to try to break this up into a whole bunch of little rectangles and try adding those up. I'm just going to say that the white region is 360 times 150 minus the green, minus the pink, minus the yellow, and that's what you see down here. But it's still all divided by the total area of the entire carpet, which is 150 times 360. And so we get 80.74%, and that's what I get when I plug all this stuff into my calculator. If you're plugging this into your calculator and you're getting something else, make sure you're careful about this. This numerator is all one big number and the denominator is one big number. And you've got the one on top divided by the one on bottom. Be careful with parentheses if you try to do everything all at once. And then the last example I want to do with you guys today is an example of a dartboard. Now, some of you may be more familiar with a dartboard than others, so I'm going to give you a little bit of a rundown of the different regions on a dartboard. This was one of our number of the day facts on number of the day 62. I've got 20 different regions here, and then there's this section here, this little thin strip around the outside that's the double. If you land a dart right here in this region, you get double of whatever this number is. You'd get double 12. You get 24 points for in that little tiny region. And then this smaller circle on the inside, this small thin strip that's red and green, this is a triple region. If you landed a dart right here in this little triple region, you get 3 times 18. Let's see, 3 times 18 would be 54 points for something in that region. And then there's the bullseye. This whole circle is called the bullseye, but then there's also a little tiny region in the middle. That's the double bullseye. Now, for what we're going to be doing, I'm going to simplify this dartboard a little bit. I'm not going to worry about all the different numbered 1 through 20 sections, but I'd like to take a look at the double region, the ring around the outside, the triple region, and then the bullseye. And so I've got these lengths written out. The width of the little thin double strip is 1 centimeter, we'll call it. This little strip is 1 centimeter. The radius of the little inside bullseye is 1 centimeter. But then the region inside here has a width of 6 centimeters and 4 centimeters. So my first question is, what is the radius of the entire dartboard? Well, we're going to go 1 centimeter plus another 2 centimeters here, plus 6 centimeters, plus 1 centimeter, plus 4 centimeters, plus 1 centimeter, all the way to the outside. That whole big long radius, all of them added together, is 15 centimeters. Which means if I know what the radius of this entire dartboard is, we can figure out what the area of the entire dartboard is. Hopefully you remember the area of a circle. If you don't, I'll make sure you go back and study those formulas before we have our quiz next week. But the area of a circle is pi times the radius squared. So if the radius is 15, the area of the entire dartboard is pi times 15 squared. I plugged that into my calculator and I got about 706.9 square centimeters. So nice big area. Now that's old news. New news today is, let's think about this. If I throw a dart at random at this board, so I throw it and it's got an equal chance of landing somewhere over here in the bullseye, but it's going to land somewhere on the board. If you're just starting to learn to play darts, you might have some darts that go outside of the dartboard, but we're going to assume that every dart stays on the board. It hits the board somewhere. I want to take a look at what is the probability of landing in the double region, the triple region, somewhere in the bullseye, or the best shot you can have, the double bullseye, the little circle right in the middle. And the way we're going to do this is the same for every single question. The probability of having a double is the area of this region. So just this little thin strip here, the area of this, you might think of this as one of the irregular figures from the last lesson. So I'll figure out what the area of that region is and then divide by the whole thing. So to find the area of this little tiny strip, we're going to take the area of the whole circle and then take away the area of this circle just inside of that, which leaves us with this little skinny donut here. And so the radius all the way to the outside is 15. This has a width of 1, so the radius to the inside of that little thin strip is 1 less than 15. That's going to be 14. And so my calculation is going to look like this. The big circle that covers everything, the whole dartboard, minus the circle that's on the inside of it. I'm going to take away all the stuff inside that I don't want to count, and then divide by, this is the area of the entire dartboard. 15 is the radius of the whole dartboard. I plugged this stuff into my calculator. I got 91.1 square centimeters for just that little thin strip around the outside, divided by 706.9 square centimeters for a probability of 0.129 or 12.9%. So a little bit higher than a 10% chance of hitting somewhere in that double region. The triple region is going to work pretty much the same way, but now I'm going to find the area. I'm going to switch colors here. I'm going to find the area of landing somewhere in this strip. And so I've got to look at what is the area of the big circle minus the little circle, where the big circle goes 1 plus 2 plus 6 plus 1. Let's see, 1 plus 2 plus 6 plus 1, that's 10, is the outside radius. And then 1 plus 2 plus 6, the inside radius, is 9. So big circle, radius of 10, minus little circle, radius of 9. And that'll give us the area of just the triple region. So pi times 10 squared for the bigger circle, pi times 9 squared for the little circle, divided by always the whole dartboard, pi times 15 squared for the whole dartboard. And so I divide that, I plugged it into my calculator, I got about 8.4. So there's a little bit smaller probability of landing in the triple region than there is on the double region, which is probably why it's worth more points. And then moving along, the bullseyes, same idea, same formula. The probability of success divided by the probability of everything. The area of the successful region divided by the area of everything. In this case, the area of the successful region, that's just a circle with the radius of 3. And so I'll have pi times 3 squared for that area divided by the whole area. Still, the whole dartboard is 15 for the radius. And so pi times 3 squared, that's the area of the bullseye, divided by pi times 15 squared. We're not going to get a very big probability here, only a 4% chance of hitting somewhere in the bullseye. And then finally, the last one is the little tiny inside, this little circle here with the radius of 1, the double bullseye. Circle with the radius of 1 divided by the whole dartboard, which was a circle with the radius of 15. So pi times 1 squared for the little tiny circle in the middle, pi times 15 squared for the whole dartboard, 3.14, which is pi, divided by 706.9, and I get 0.0044 out of my calculator, which means it's only a 0.44%, less than a percent, less than half of a percent chance of landing in that region. So that's the idea, using probabilities. The probability of a successful region divided by the probability of the entire region, whether we're talking about rectangles or circles or triangles or whatever. That is how we do geometric probabilities. As always, if you've got questions, some people have been weighing in on Google Hangouts, or you can send me an email. But we will be reviewing on Friday, and then probably also on Monday. My plan is to have the first quiz of this new distance learning time period on Tuesday. So more on that later, more on the review as we move forward. Good luck on the homework assignment. Let me know if you have any questions. All right, bye-bye. Peace out, Home Slice.